Hi, I'm Tom Stephenson and welcome to Wood Framing Basics Explained. I'm a professor of construction management, and in this series we're looking at how to understand construction drawings and the things that you need to know to effectively review drawings. And for sure, in residential construction, you need to know the terminology that everybody's using. You need to know the terminology that everybody's using officially, and then you kind of need to know the terminology that people use on site as well. So I'll try to clarify and compare and contrast. And we'll also look at more traditional materials and some engineered products as well. All right, so let's get started. So framing basics. We have our building structures, and everybody knows what the outside of a building looks like, but they don't always know that well what's underneath the skin, what's underneath the overall finishes, exterior finishes, interior finishes of the building. And so what we want to do is sort of rip that cover off and look below the surface and see what we can actually see on a particular house or residential drawings. And what do they call it? Because they're going to say things on construction drawings and you might not know what it means. So you got to get the basics first, and then you can start to build from there. So we'll start to talk about what are some of the things that you need to know. Well, in a basement foundation, you've got floor joists. Now, these are kind of representing what we call dimensional lumber floor joists, and that's made out of solid lumber. May not be the most common right now. I would say manufactured joists are much more prevalent, at least in the area that I'm in, Greater Toronto area, but other cities in North America you probably find similar. But there might be some jurisdictions where this is the prevalent material that's used. So it just depends. But dimensional lumber for decades and decades been very popular. If you're working in renovations, any house that's probably older than 15, 20 years, you're probably going to run into dimensional lumber from that perspective. And of course, floor joists, which are the horizontal members that are placed on top of the floor. And then we put plywood, which we call a subfloor, over top of it. And so underneath and supporting those floor joists are beams and foundation walls. Now around the foundation wall, underneath the rim joist, we call this joist that goes around the outside, a rim joist. In some areas, they may call it a header joist, although I would say that's not the correct terminology to use. And the other is that you may call it a perimeter joist. I've seen it called that too. I tend to call it a rim joist. It sits on a sill plate, which is usually a 2x4 that has anchor bolts that are seated into the foundation wall, and that's really the tie between the floor framing and the foundation wall. So we have a sill plate, we have a rim joist that goes around, we have our floor joists that go across. We might have a built-up wood beam, which is several layers of joists that are nailed and or bolted, or both together depending on the specification. Or it may be an engineered product such as an LVL or a PSL. LVL stands for laminated veneer lumber, and it may be supported on a post or column. It's used both terms. All right, a post or a column. We've got the beam that goes across. We've got the floor joist, because this is dimensional lumber. They're lapping past each other. Okay. And this is giving you sort of a plan view look at this. It's talking about spans, but I'm not going to get into that right now. So you're looking at this in plan view, so you can sort of see the joist, you can see the built-up beam, and you can see the foundation wall going around it. And of course, then this is the supporting column, which would be below it. Now, within a floor system, you have openings, for your stairwell opening or for other purposes, whatever that may be. It's usually not going to be a perfect floor, because usually there's going to be a basement or access to another floor. So we usually call it a stairwell opening. Wherever we've got these openings, we have members that go across that support joists that have been cut so that they can open up in this area. These members are called headers. Now, headers support floor joists. Trimmers support headers. So just think of it this way, that this double header in this particular instance is supporting all the floor joists in between. So from this point to this point, you could have a much wider opening, and it would be supporting all that weight, and it has to distribute it to the sides. So usually on drawings, it might say DJ for double joists or TJ for triple joists. You know, wider opening is going to take more joists to support that. Now, the trimmers are then supporting not only the headers, but the weight of those floor joists. So they have to be even stronger than the floor joists very often. So often you might find they're tripled and the headers are doubled. But these are called trimmers. So trimmers support headers and headers support joists. That's the difference. So if you're wondering, you know, because people always get them mixed up, what's a header and what's a trimmer? Now, headers are in floor systems in Canada. We only call them headers in floor systems. We'll talk about that with the wall systems, because in Canada we call them lintels. In the US they'll call it headers, I believe in their building code, as opposed to ours, which we'll call them lintels. But in a floor system, it's always a header and it's always a trimmer. So keep that in mind. And the shortened joists we call tail joists, because they're not the full length, so they're tail joists. They've been shortened. All right, full length joists, they're just called joists. Doubled up, they're called double joists. Forming a beam, 3 or 4 of them, they're called a built-up wood beam. All right, so then we have an engineered floor, and an engineered floor is exactly what it sounds like. It's been designed and engineered, and it's made not from dimensional lumber, but basically a manufactured product. Usually it consists of a web and a top chord and a bottom chord. And so this basically is in the middle, and that's why they call them I-joists. And the part that's in the middle is usually made out of some oriented strand board. It can be made out of different materials depending on the manufacturer. That's why it's engineered, and it is not made from dimensional lumber. It is stronger than dimensional lumber in that it can span greater distances. So that's one of the reasons it's become very popular, is it can span really long distances, whereas dimensional lumber has its limitations. You know, you're probably going to span out at around 18 feet with dimensional lumber, but you can go much longer without a support with an engineered product. The other thing is, engineered products don't shrink the way natural wood does. Natural wood, dimensional lumber, 2x12 can shrink, 1/4 to 3/8 of an inch, depending on the moisture content of it. I've talked about that in other videos, and I'm sure I'll talk about it again in new videos as well. But you can check my playlist if you're enjoying this so far. Please click subscribe, and you can check under the playlist, under the residential construction playlist, and under the understanding construction drawings for more videos in this particular area. I have quite a number of playlists. And so moving on then, spacing. Well, if we've got an engineered floor system, or we've got a standard dimensional lumber floor system, they typically will be spaced at standard spacing, which is the space referring to the space between the members. So in wood frame construction, you'll hear about on-center spacing. And that simply means from the center of one member to the center of the other, or from the left side of one member to the left side of the next member, and so on. The spacing works out so that it will fit standard sizes of plywood, which are 4 foot by 8 foot. Therefore, the standard spacing is 12 inches, 16 inches, a little bit less used, 19.2 inches, and 24 inches. So we've got 12, 16, 19.2, 24 inches. So you can see the 12-inch divides nicely into 4 feet. The 16 divides evenly into 4 feet. The 2 foot divides evenly into 4 feet. The 19.2 divides nice and evenly into 8 feet. 5 times 19.2 gives you 96 inches. So the spacing for floor joists is a direct relation to how far the joists are spanning, the type of finished material you might be putting on it, the thickness of the subfloor required for it, So it's a number of factors that go into that, from building code requirements and the design side. For example, if you're putting a ceramic tile, it'd probably be preferred to have a 12-inch spacing so you have less deflection on the joist. These kind of things go into this, to the design and to the spacing of the joist. If you're spanning a longer distance, so it's sort of at the end of that joist's ability to span that difference, they'll probably bring them closer together, and that might allow them to span a little bit further with those members because of the strength being spread out amongst the members. So you'll see that that's where the different spacing comes in. Engineered joists, another advantage of engineered joists is you can usually get pretty large holes put into the joist to run pipes and different other elements through them, although it does have to follow that manufacturer's specific requirements. Whereas dimensional lumber, it's pretty standardized in the building code what you can and can't do as far as drilling and notching goes. And I won't get into that in this video. But there's your standard spacing: 12 inches, 16, 19.2, and 24 inches. Same thing goes for walls. So you'll see those standard spacing. Probably the most common would be your 16-inch on-center spacing, which is a pretty standard size depending on what's being used. But again, you always have to look at the drawings. All right, so here we get into the members. We've got vertical members, which are called studs. You can pardon all the jokes around that, but basically these are studs. And the one that's just that beam that's going across here, we call it a lintel. Now this is where it gets interesting. In Canada, the building code describes it as a lintel. So you don't want to be looking up a header in the building code and you're going to find something for a floor, like I just mentioned. You want to look under tables and information about lintels. But on the site, everybody calls it a header. In the US, everybody calls it a header. And so we kind of just do that on site. Usually when you're a professor in construction management like I am, you really sort of take this hard line that you got to call a lintel. What I usually tell my students that are going out there, fit in. If you're talking to framers, they'll probably say, what are you calling it? A lintel? Call it a header. If you're talking to a building inspector, call it a lintel. They'll know that you at least understand the building code from that perspective. And the construction drawings themselves will call it a lintel typically. All right, so like the ones I've been using, Cassidy and Company, very good drawings, they'll call it lintel. That's because that's what it refers to in the building code, and that's what it's designed to. So all of those beams going over your windows and door openings, horizontal in the walls, are lintels. These look like it must be for a load-bearing wall because they're done on edge. If they were done on its flat and it was a single member, then that just means it's a non-load-bearing wall. So load-bearing walls carry the weight of other floors. Non-load-bearing walls, well, if they're there or they're not there, it doesn't really make a difference. The structural integrity of the building is not compromised. If you take out a load-bearing wall, the floor above could fall on your head. So you want to know the difference, especially if you're doing renovation work. We generally go with a top plate. I can talk about optimum value engineering and basically how we can reduce thermal bridging and things like that. But generally, you can assume that there's going to be a double top plate and a single bottom plate in the framing. And below here, we've got our rim joist, like I mentioned. And below that, we've got our sill plate that's attached to the foundation wall. There will be some form of bracing typically, unless you're using a structural sheathing bracing like a plywood, and that may be metal, usually not wood cut in because that's too much work. Usually the metal strapping is what's the easy thing to do with a saw kerf on an angle to get that those members in place. And like I said, so the spacing between your studs could be 12 inches, 16 inches, 19.2. 19.2 has gained popularity depending on the building code requirements because you can use fewer studs and you can buy standard spacing insulation for that. And using fewer studs, that's less expensive from a lumber perspective, but it's also a good thing because there's less thermal bridging of the cold of the warm moving through to the cold. So warm travels towards cold, and it'll travel much easier through a 2x4 or 2x6 than it will through insulation. So those are some other little tips here. platform construction that it's mentioning here is referring to how we build. We build a platform, then we build the walls up on top of it. We build another platform, then we build the walls up on top of it. These notes and drawings here are taken from CMHC, Canada Mortgage and Housing Corporation, wood frame handbook that they have. And I'm going to provide a link in the description below. It's a free download, so you can try that link. You might have to copy and paste it in, but it is an excellent book that CMHC has put together. I would say it hasn't been updated in a while, so whatever you see on insulation and things like that, new building codes, of course, are much more robust as it comes to that. So don't follow it too closely, but generally for framing and that, it's pretty good as far as its representation of what's going on. There's a few things that are a little bit dated in it, but generally it's pretty good. So here we have our roof framing trusses, and so a truss roof. So we talked about floors, we talked about walls. Well, again, trusses, most frequently they're done at 2 foot on center. They're very strong. They can span long distances. You can order them just like you can an engineered floor. So the assemblies are pieces that are pre-assembled, and so they can be assembled very quickly on site with less skill than, say, is required for a cut roof, but it still requires a fair amount of skill to make sure that you put it up properly and that nothing is damaged during that process. So the roof trusses, you have your common trusses, which is just your regular roof trusses. Here you have girder trusses. Now girder trusses typically support other trusses. So a girder truss usually has like jack trusses running into it in some way, shape, or form, or other trusses that are being supported on it. So like these trusses coming down, depending on how it's laid out, could be in that particular case. So girder trusses support other trusses, so it's like a beam in that sense. And then we have our valley trusses in this case, which sit on top of another trussed roof, so that will create the valleys, where you have 2 directions of slope running into each other so the water can run down. Very quick to assemble. They're just a bunch of members that are cut, and they're held together with what they call gusset plates, which are these metal plates that are sandwiched between the joints. But they are very vulnerable until you get them into place and until you get everything nailed and you get the sheathing on. So you have to make sure that they're properly braced and follow the truss manufacturer's requirements, because they are engineered. And your local building department, they would want that manufacturer's floor joist engineered drawings, and they would want that truss manufacturer's engineered drawings to review before you install them. Now, roof framing traditionally was cut on site, and so that meant that you had to measure the span, you had to figure out what the run is, which is half the span, and then what the slope is, and then you would lay it out. So 9/12, you'd hold a framing square at 9/12, and you'd step it off till you've stepped off enough that you've stepped off half of the span, and that'll give you the slope. So basically there's a lot that goes into cutting a roof on site. I have other videos, again, under my residential construction playlist that I go into that in more detail. But you really have to, know what you're doing as far as laying out a cut roof to do it efficiently, to do it effectively. There's a bunch of terminology that is used for this. And so we have, again, our common rafter is the rafter that goes from the top plate directly to the ridge. The ridge is what joins the rafters on both sides. This is basically a gable roof. You've got a common rafter coming up this side. You see these horizontal pieces? It's called it says collar brace, or collar tie. That's what I was going to say. That's what it's usually called, is a collar tie. And that allows to use smaller size members because it really stabilizes the roof. So collar ties are generally put in, usually around half height or somewhere thereabouts, because it can dramatically reduce the sizing of the members that you need and dramatically strengthen the roof members. Ceiling joists, in this particular case, they will lap over and then they rest on a bearing wall. That wall becomes a bearing wall. With a truss roof, the bottom chord, in most cases, will be non-load bearing, meaning that it doesn't require a load bearing wall underneath it, right? So that's a big advantage. You can span really wide distances without having to have a load bearing wall underneath it. Can you imagine that? Like if you're a designer, it gives you a lot of flexibility in your design and your layout on that second floor if it's a two-story house, or on that bungalow if you want to have large open areas. It makes it much more easy than framing with a cut roof on site. So cut roofs use more dimensional lumber. You're going to be using larger members to span further distances typically, because our houses are bigger than they were 50, 60 years ago. And again, there's a lot of terminology. So common rafter goes from top plate to ridge. Jack rafter is just a shortened common rafter. So in this case, it's a valley jack because it is going from the ridge to the valley rafter. And the valley rafter is where two intersecting roofs come in to meet. A hip roof is on the outside, which is different than a gable roof, which sort of has a straight end. Hip roof has sloping on both sides. Sometimes we refer to it as a cottage roof as well. Don't know why, but that's what we, in our jurisdiction anyways, but generally it's a hip roof. And so we have hip jack rafters that flow into, from the plate into the hip rafter. So the difference is here, the rafter's flowing up from the plate to the hip rafter, and here they're flowing down from the ridge into a valley rafter. And of course, if we're doing a truss roof, the valley is what's happening when you do this particular design. So that's just giving you a little bit of a heads up there on the different terminology, which is helpful. It's, you know, there's a lot more terminology that comes into play, but I thought I'd get you this basics video before we go too far in trying to read our drawings, so that you kind of have a good idea of what you're looking at. So in this particular case, which I talked about in the previous drawing, and it should pop up the previous drawing on your screen. So if you want to go back, previous video, if you want to go back to the previous video, you can do that. So you can click on the playlist as well. But you should see the joists and now have a better understanding. Okay, they're spanning this way. This is a steel beam here. This is a column, support column over top. Here we've got cantilevered joists, and they're cantilevered out past the wall. So we're starting to get a better understanding of the terminology. And like on this set of drawings here, it says 38 by 184. They're metric. If you're US based, like I've said before, I'll be using more imperial drawings as we go forward. 2 by 8 spruce, number 2. That's basically what kind of lumber. What do you use in your area that's popular, but it's designed by strength? And this would have been the same as saying 12 inches on center, even though it's not exactly the same. We always frame in Canada. Doesn't matter, our building code is metric, so we kind of have to deal with that. But very often, you know, that's fine. It says 300 on center, but when we lay it out, it's 12 inches. If it said 400 on center, when we lay it out, it's 16, because our sheets of plywood, our drywall, everything is imperial, 4 foot by 8 foot. And we ship 10 times that to the US, so that's why we stick with it as far as our material of choice here whenever we're doing anything in construction. It's always good, though, to know, even if your jurisdiction uses only imperial, it's good to know both methods. You never know where you're going to be working, where you're going to be traveling, and what changes may take place. So hopefully that gives you a good understanding. We've looked at the different types of floor joists. We talked about headers. We talked about trimmers. We talked about joists and tail joists. We talked about sill plates. We talked about bottom plates, top plates in walls, the studs, the lintels over top of the openings. What I didn't mention was underneath an opening, like a window or that bottom horizontal piece, we just call it a rough sill. And shortened studs are called jack studs. Shortened studs are called jack studs, whereas shortened joists are called tail joists. So we have a name for everything. We just got to get used to it, and hopefully this gives you a good introduction. Again, if you enjoyed this, please click subscribe and join the YouTube community. Ask construction questions. Give me some ideas for future videos, and we'll take it from there. I'm Tom Stephenson, wishing you a wonderful day, and we'll see you next time. Bye for now.